All right, let's use our knowledge of derivatives to think about a real world application. Let's say our business's cost as of last year as a function of the number of items we sold. So depending on how many items we sell, our cost changes. And the function that gives us our cost as a function of the number of items we sell is given here. So notice it's a negative leading coefficient on a quadratic. You know that your cost function is going to look something like this, right? You know it's concave down. All right, so this is our cost function. Right, let me underline that cost function, try to keep the colors the same. So that's my cost function in yellow. So first part, we want to evaluate the marginal cost at 50 items. So note the marginal is just a fancy word for derivative. The marginal cost as a function of the number of items we sell is the derivative of your cost function. So by the power rule, this cost function differentiates to minus 0.04 in plus 11. So the derivative of the cost function, the function that tells me how my cost is changing, is, let's do this in green, a negatively sloped line, but just barely, just 0.04 units per unit. So with a y-intercept of 11. Gonna look something like this. Okay, so I want to evaluate my marginal cost at 50 items. And this is what this is asking me to do. My marginal cost at 50 items. So that would be minus 0.04 times 50 plus 11. And I'll save you the algebra. You get 9. So let's assume that everything is measured in US dollars. Then this tells me that my cost is increasing $9 per item, right? That's how fast my cost is changing as the number of items I sell changes. So as I increase the number of items I sell, my cost goes up by $9. All right, let's work on the second problem. Let's actually find the change in my cost as I go from 50 items to 51 items, right? Because I have my cost function, I can do this. So to figure out the change in my cost, it'd be the cost at 51 items minus the cost at 50 items. So go back up to your cost equation, evaluate it at 51, and then subtract the cost function at 50 items. And again, I'll save you the algebra. Your cost at 51 minus your cost at 50 gives you $8.98. So notice the similarities between these two items, or these two numbers. Your derivative at 50 items was $9 per item. So your cost is increasing at a rate of $9 per item. And in fact, you see that with your original cost function. As you go from selling 50 items to 51 items, your cost increases $8.98. So you're using your derivative as sort of like an estimate for your cost function, right? If you know your current cost and how fast your cost is changing, then you should be able to estimate the cost of the next item, right? Our derivative told us that our cost is increasing $9 per item, and the actual change in the cost is about $9 from 50 items to 51 items.